Hi, today the main topic is the address decoding. So I'm just gonna explain what is address decoding or why we need such address decoding. But to elaborate more about this, I'm just gonna talk about the important part what I learned. As you also know, we are using CS as segment, post segment register, right? And there are other thing, IS, uh, program counter, program counter. So, um, you know, the CPU use this core segment register or ISPC register or those kind of SS stack segment register and SI stack SP stack pointer. The these registers is the just the is a storage in the CPU. There are general purpose of the register and special purpose of the register. And special purpose of the register is register inside BIU, this kind of thing. And general purpose of register is what we know as AX. AX can divide into AL. And the difference between the AH and the AL is the high bit, just the low bit. They're just split into the 8 bits. This is it. And the BX and CX. And but the thing is that how CPU use this kind of register to do something, right? There should be a purpose of using this register, right? You know, we also define as CS, IP, and the purpose of these registers, using this register, is to get our next instructions. I just talked about instruction yesterday. The instructions are the basic function of the CPU. Example, the move or jump or pop or push, and those kind of feature in the CPU are known as the instructions. And we store our next instruction in some kind of memory. And to get the memory, we can use CSIP. And when I first encountered this, and I thought it was really easy because we can just use CSIP formula. The formula is CS time the core segment register is storing the offset, stores offset or the base address of the memory, and times 16 plus IP instruction pointer. This is gonna be the pointer address. The pointer value could be appropriate. And this formula is very simple, and I thought that was the way. I thought it was the way of the fetching physical address using this formula, but it wasn't. What do you mean it wasn't? Yes, it wasn't. Just using this, one get the real physical memory of your address. And what is this for? This is for logical address. The what I believe of the logical address of the and the physical address is the physical address is the real address of your memory, and the logical address is relative address of your memory, physical memory. So that is the big difference. You have to change logical address into physical address, right? And if I try to draw the flow of getting the memory address, this could be like this. Example, we have CPU, right? And we use inside fetch next instructions, we use CS IP information, and then we get the logical address, right? logical address, and then we use address decoder to get physical address. But the thing is that understanding this address decoder is really hard because you should have basic knowledge of the memory, how to get the memory size based on the specification. And that really made me confused because I just studied this concept today. So and it was really confusing. And I'm just gonna explain the core concept or the important part that I learned. This is the question. And let's assume that we have a simple microprocessor. The processor is just like CPU. Processor with 10 address lines. So there's a processor, CPU, and 10 address lines. I don't know how to do it because this is my first time. I think this is the line. Let's just, it has 10 times address line. And that equals to 1 kilobyte of the memory. And also, let's assume that we have a memory chip and we use 128 times 8 memory chips. Yeah, I know this is really confusing. What's the 128 means and what's the 8 means? The 128 means that each chip has the 128 address and the size of it is per 8 bits. And what is the size of the memory chips and what is the quantity of quantity of the memory chips, right? So there's a formula of you. This could be wrong, so I'm just still learning it. The memory specification of 128 times 8 times 8 means that we need to have 8 chips because I believe this is the how many chips I need, and we need to have the 3 address line to select each one of the 8 bits. So we need 3 address line and we need 7 address line ADDR, 2 address each the internal memory cells. And how does 3 and 7 come from? The 2 7 equals to 128 and 2 3 is equal to 8. But I just really confusing. And my general question is why how we came from this? Why we had to get this number from this kind of specification, and what is the background of this? And I didn't still figure out it, but I'm still doing it. So I'm just gonna figure this and I'm just gonna study more about this, how we end up using this formula deeply. And I think tomorrow I'm just gonna talk about this furthermore. And the reason this is important because based on this we can see how this line works, the physical hardware works. So example, this is CPU. And we just assume that 10 address lines, right? 10, and we just get the value of 3 address line to select each one of the 8 chips, right? So it's gonna be 3 and 7, and that could be 3 to 8 decoder. So But based on this kind of hardware specification, we were able to get the which decoder we should know. And I found out this is really hard because you have to know about the logic gates, the NAND or NAT, or the hardware specification. And I really don't know if this is really practical or not. But I believe this is a really fundamental thing. Like logic gates, circuits. We have to know about circuits first to understand RAM. And to understand SRAM and DRAM, to understand RAM, we have to know about SM and DRAM. If you know about SRAM or DRAM, and after that we're able to learn about RAM, right? And after RAM, we're able to learn about ROM, and after that we were able to construct some kind of this kind of the getting this instruction based on that. And everything is related, and it's like a spider web. It's everything is related, like logic gates and those kind of stuff, and this is kind of tired and boring. It could be boring, but for me it's fun. But it could be boring for you. But what I'm trying to suggest is, if you're a front-end developer, use TypeScript or JavaScript to represent this kind of logic. How do we describe it? In the CPU, we have a fetch functions, and in the fetch function, we use the call segment register and instruction, the instruction pointer, right? And to describe this kind of logic into the code, we can just use class, right? The class CPU, and there's gonna be method of the fetch, and there's gonna be the private variable called segment register. Of course, call segment register could be defined as the class or so. So we can just define with our own code rather than speaking with our mouth, because this is kind of practical, right? You can just make your own operating system, even though you cannot make it because of the language limitation. So that is what I'm trying to do right now, making an operating system, but in the front-end browser level, which means that I have to specify all the hardware specification by my own. And I believe this is really worth it. To know about fundamentals is very important, I think. So this is it. Have a nice day. Bye bye.